Today I want to talk about data science as a product discipline and look at almost a journey, if you will, of my career over the last 3 years as if you guys know this building over here called RainFocus, just up by the Tacoma Highway. I was the 10th employee there, found their data strategy and helped grow them from 10 to 200 employees in 3 years, and was focused really on the data side and saw successes, saw failures in what worked and what didn't, and helping use our data to help benefit the customer experience. I wanted to talk about the disciplines that I saw and put together in that journey and how we're using that in the industry today. So by show of hands, as I want to get them to know the audience, who here has been in data science for like less than 2 years? Who hasn't ever been in data science? It's like looking to get into data science. And then 2 to 8 years, anybody? Like 8+ years? Yeah. If you would have said 8+ years, it wasn't a term like 8 years ago. Like before it was, I mean, I went to school wanting to get a degree in actuarial science, and like that was the closest that what existed to data science 10 years ago. I want to kind of start off and get a little bit of engagement and ask you this question and maybe look at it from data and data visualization, how you would view time. So there's 3 ways that I've come up here. There's time to view left to right. So who's ever sat there and said, okay, I want to see my data and I want to see it from left to right? And then who's seen it bottom to top? And then who's seen it top to bottom? What is any preferences on the way the data looks in terms of left to right, top to bottom? In a database, it's stored top to bottom, right? And when you ask a non-technical user to look at the data, they want to see it left to right. Like rarely do you, like if they want year over year, they want year 1 on the right side, year 2 on the left, or next right side, year 3. Top to bottom, for anyone that's experienced in like data exploration, that's the quickest way to go and find valuable data, is to go and look into your tables and then sort from top to bottom, and you'll see that the most recent data is usually the best data to use, and a lot of people archive their data by just forgetting about it and never looking at it, and it sits there at the bottom unused. So I'll tell you though that if you can break yourself from thinking about time as a directional resource, you'll realize that putting time in a directional box is quite limited in terms of how you can use it for a resource and an asset. I'll get to that. To give you an example of the industry I come from the events industry. And what you're looking at here is a cruise ship that Salesforce had to park in San Francisco Bay because they ran out of hotel rooms in San Francisco to host their event. And when we were getting a SaaS platform off the ground to help events industry configure their event, this is the type of things that we ran into that we had a solution for, kind of on the fly. Both, yeah, we can do that while someone's in the background hooking up all the wires, and then thinking about, okay, well, how can we do this at scale? And as we started to work in the enterprise event industry, what we started to have was enterprise data problems and ways to utilize that data for the enterprise level. And what we had to do to provide intelligence for this industry was look at the data that we were collecting and figure out how to make it as a product rather than just a service, getting people their insights and their utilization. So I remember, I was 4 weeks on the job, and I built like this clustering algorithm to show like, okay, here's cluster 1, and this is what it means, and here's cluster 2, and here's cluster 3. And it was so, they didn't know how to receive it. Like no one knew how to kind of act on it. I didn't know how to deliver it. And it was a sharp learning curve to see like, okay, you can't just go out and do these one-off cool tricks on the data just to kind of try and show off what can be done with data. You really have to take an approach that says, okay, we're going to use the most valuable data assets, and we're going to productize these. And we're going to productize them so that they're going to give us value over and over again for every customer that we sign on. And so what I want to go over is kind of what a data product looks like. And when I say a data product, what that means. So at RainFocus, when I was there, one of the things that we quickly realized is that 95% of what they want is reports. And what people see as like data is they picture it like Excel spreadsheets, and they want to be able to pivot those Excel spreadsheets. And if you fight that, you're going to have unhappy customers. You're going to have unhappy people. So we built a report builder. We built out-of-the-box templates that non-technical users could open up and add columns to. And we actually built it as our own application. So we didn't go out and acquire a BI platform. We actually built it from the ground up to provide just a seamless, catered experience for the events industry. We had automatic aggregation so they wouldn't shoot themselves in the foot. If you guys have seen that before, you get the many-to-many joins where, you know, if someone books 2 hotels and they go to 3 sessions and someone wants to see a report with both of those pieces of data, they get 6 rows and then they report that revenue. Next thing you know, they've tripled their revenue under thinking it's tripled and it's not. So that's a tough conversation to have. We built out-of-the-box core reports so that they could see those. And dashboards. Now, everything you see here, we built for SAAS customers to sign up and they get that out of the box. For every customer, every event, they could build a report for one event, switch their variables or switch their event and see all of their data for the next event and so on. We started to unhinge that data value and built a recommendation engine. So what you're seeing here is that yellow banner that gives a thumbs up or a thumbs down and this thing that says this session is recommended for you. And then an engagement score. We started to crack open pegging down an attendee going to an event and based off of the engagement that they had at the event, identifying their primary product that they were interested in, and also letting a non-technical user configure how they would weight different activities at the event. So think of going to a session being more valuable than visiting the website in terms of lead engagement. And that's what these events were a lot about, was trying to find valuable leads and how to find what they were interested in at the event. And what I started to realize and what we started to realize is that really, has anybody seen the analytical maturity pyramid here before? So down here we've got descriptive data. These are things like reports. You got diagnostic data, predictive, and then prescriptive. Now, if you've never seen this before, I've got some examples of different things that a data product would roll up into. So if you think of your descriptive layer being the least mature you can be in your analytical strategy, these are things like basic reports. So the raw reports that people want to see, the APIs that are getting passed and forth, and then just the data that exists. And the reason why it's the lowest level of maturity is it's the hardest to gain value from other than an operational level. The next level up is diagnostic layer. So being able to ask questions of your data and get a better understanding is the next level up of how you would picture analytical maturity. And these are things that like visualizing your data. So all of the BI platforms today, that's about to where they get to is being able to diagnose the data, being able to show bar charts, ring charts, being able to filter on those bar charts and ring charts, being able to collaborate back and forth on questions and answers of the data. The next level up gets a little bit more technical, and that's being able to make predictive insights. And so a lot of you guys here are the machine learning phase. Really, you start to get into this predictive level, right, where you're starting to consider your forecasting, you're starting to look at your recommendations engines, trying to find drivers of the data, things that are statistically significant. At the last is being able to actually, based off of the data that's given you, make the optimal decision and take the optimal course of action to better your business going forward. A couple of things in this prescriptive realm. One being recommendation engines, which I think is exploding right now in people's understanding for e-commerce. And it's a simple, low-hanging fruit for a lot of customers and a lot of companies. But yes, this is the analytical maturity lifecycle from a data product perspective. And if you can think of it from a product perspective, you think of the data that you collected and think, okay, every single data point, every single table has an opportunity to present itself in a maturity pyramid like this. I can build basic reports and raw data on it, but I can also build visualizations on it. Start to make data-driven decisions. And if you start to take the approach of data going upwards like this, rather than looking at all of your data and it being all scattered and then trying to find value from it, it really starts to make sense how to piece together valuable data in a bottom-up approach, rather than just trying to think of a cool machine learning project that you can do or a cool dashboard. Yeah, go ahead.
What's auto ETL?
Automated ETL?
Yeah.
Yeah, so what we did here, so we talked about being or shooting yourself in the foot, right? Where you have this many-to-many join. And so what we did is we took, we took a parent-child relationship between the data, and based off of categories and tags of that data, we were able to automatically determine the topmost parent and the bottommost child and the way that the data joins, and detect that if a parent had 2 children, that one side needed to be automatically aggregated so that we didn't create that many-to-many join. And we did that through just a lookup file to say, okay, take an attendee, right? An attendee can have multiple orders, and an attendee can book multiple hotel rooms. And so if you block that out and say, okay, I have my attendee as my topmost parent, and 2 children, orders and hotels, as my next 2 children, and someone drags on columns from both sides of that, we detected that that automatically needed to aggregate one side of the equation so that we didn't create 6 rows of data when there really only needed to be 3 rows or 2 rows, one of the other side. So that's kind of what we did for automatic ETL. And this was, we were able to bring on, think of an attendee with children, 7 different children, so sessions, hotels, orders, payments, and then another grandchild relationship. And so we could bring in something like 1,500 columns worth of data that no matter the combination that they made, we were doing automatic ETL on the data to say, okay, this is aggregated, this is a subquery, and then all of it still filtering or changing based off of the event that was selected and stuff like that. So, yeah. What I will say though is, as you show this to people and people try and internalize it, and how does that work for me, you do have to segregate your mind into those that are the technical users and those that are the non-technical users. And as you think of the non-technical users, these are the people that are going to get excited about reporting. They're going to get excited about their BI tool and the visualization layer, but really trying to coach them and bring them up towards thinking about a machine learning algorithm or thinking about even a forecast. You're really going to have a hard time getting them to hop. If you're working on them, teaching them how to build reports, and then they're getting really excited about visualizations, it's going to be a long road for them to learn how to actually start making predictions and start using predictive analytics. And similarly, if you have someone that is super smart in the data science realm, peeling that back into a business strategic layer of those that know their dashboards in and out, and how to listen to a non-technical user talk and break out all the ways that they need to see the report. It's actually a good gap to try and get them to be super proficient in the reporting realm as well. So if you guys were to look at this and think, okay, what quadrant here, if you will, is the most valuable level of where you can focus your data investments. So at the end of the day, it costs money, right? And where do we put our money to provide the most value? And to me, I put a little emojis on the right side to think of myself and my journey and trying to bring data products to customers and find what was the most valuable thing for them. And what I found, so I'll go through this, right? So think of reports, APIs, here's all your raw data that you've been asking for, and finding that they're complaining and saying, okay, that's not what I want. I want to be able to visualize this data. I want to be able to see it better. And what I found is if you put out one thing without the other, it's still not valuable. So giving them just a BI tool with a blank canvas and handing it over to someone who doesn't know how to, someone who you have to teach how to sort the data, right? And you have to teach how to, what a pivot table is, right? If you hand them over a blank canvas of a BI tool, it will be hard pressed to get value from them because they don't want to build reports. People don't want to build visualizations. They just want those visualizations for them and taught how to interact with it. And it was hard trying to take the feedback that I wasn't providing value by just adding a BI tool or even creating. But on the flip side, I found that the next two layers on their own are also not valuable. And so this is what I'm going to say, right? So what I did find is you take the pyramid in general, and you've got to think in terms of you can't eat the elephant, or the only way to eat an elephant is one bite at a time. And when you think about product and the way that people release product and how they put out value in their product, in general, in SaaS, you think of building a small thing that gets you closer to the end, and then building on top of that, but getting customer feedback. And so what we started to realize is that rather than say, okay, we're going to release all 200 of possible reports, and then when we're done with that, then we'll move on to visualizing that, and then we'll move on to predicting user behavior. We had to think, okay, what can we do that will get us, what can we do to use machine learning and to use a recommendation engine, but not have to tell the customer base no on what they were asking for in terms of reporting and visualizations and how to use that data. And so what we started to think about is actually breaking out the three main components of what customers are looking for in their data and build those up simultaneously and together. So what we had to do is segment the teams out into three teams, so three disciplines. The first discipline being a data tools team, the second one being a BI consulting team, and then the third discipline being a data science team. Now, the data tools team, this is a group of hardcore developers, SaaS style, that is responsible for the code development and deployment of a BI tool set and the tools that it takes to be able to use and manipulate your data. We found that if you try and get a big team of superstar experts of data, like data experts, you're going to miss out on the customization that your customers need and be able to put forth effort towards the BI and tools that you really want to enable. So they call themselves Datatron, built an entire BI tool from scratch in under a year. And through that also built the configuration of engagement scoring. But these were developers, right? What we were able to stay agile, release iterative deployments of code, but found that developers will always attack the same problem the same way, right? they'll architect a solution, they'll build things from scratch, but really they're on the opposite end of what data science is. There is no data when a developer starts to think about what product they want to make, right? The data doesn't exist, and so you can either, we found that we wanted them to be focused on the tool sets that needed to be created to help enable the data utilization, but that slowing them down by forcing them to think about what the data was going to look like and how it was going to be utilized was not a skill set that they had or that we wanted to go, or that we needed them to have. And so that was really what we found in the data tools team, is that they were focused on just development. And there was back-end developers, front-end developers, but really not a data expert in terms of what they were building. The next level was a BI consulting team. So think about how much data gets collected and customers that are asking to be able to make more data-driven decisions and the analytics that they want. That can take a really long time to build from a product perspective, especially if you're thinking about, okay, I want to hear feedback. I want to build better dashboards for them. They're asking to be able to analyze their session tracks and the user behavior. And you're thinking, okay, well, if I build a product for that, it's going to take me 18 months. And one customer is asking for it, maybe not the other. We found that we could be much more agile in our product development by servicing those customers through a BI consulting realm as a service. And these guys were great at knowing exactly what the data could tell them, what insights they could gather from the data. They were data literate. They were able to advise the customers on how to use their data to the maximum potential. But I'll give one statistic here. So with over 5,000 reports created per year, and this is, think of, we had 1,000 end users building their own reports. And of those 5,000 reports and 1,000 end users, the BI consulting team of 5 people built over half of those reports. So they're the ones that can crank through creating all the different levels and slices and dices and the way people need to view data. But one of the biggest problems that we had with them is that they're creating most of the tech debt that we were having to dig ourselves out of because of the way that the moment you put out a product for people to use the data, and they've never had that before, they're the ones that are going to break the tool to be able to bend the data to do what they want to do, right? So if you're thinking, okay, we're going to put out a dashboard that shows the number of registered attendees, and we're going to break that number of registered attendees by date, and then we're going to show the primary product of these number of attendees, and you launch that as a product, the BI consulting team will bring that to the customers, and the customers will pick apart 10 different things that they need, and those BI people will go back and manipulate all of the queries to fit that one use case. And all of a sudden, if you want to migrate and update your product, you've got this nasty, hairy tech debt thing that you've got to also think about migrating up as well. So that's what we found with this BI team. And one of the best things that we found in creating a better data product was that they were the #1 arm for us to bring feedback on how to improve our data product. So we would use them as a direct line to say, okay, what is wrong with the data and the utilization of our customers today, and how do we fix that? And they could target exactly how to do it, and we didn't have to go spend as much time listening to the customers trying to articulate the same thing, just because they weren't able to quite put it into words in terms of what was wrong. If that makes sense. The last discipline being data science. Now, this was an interesting one for me because data science can think so far in advance on how to use data. And it actually, if you think about new data coming in or new structures of your data as your SaaS product is getting created, it's actually pretty slow. Take a table, it's not very often that new columns are added onto that table, or take a new table or a new database. that in terms of how often that's happening compared to like deployment of code is at a much slower pace, right? But the thought process and the testing and the design and thinking of all the different ways that the data is going to trickle in, that can become quite complex. What we did find is, so at RainFocus, there were 75 developers and 9 different product teams. And a data science team, we needed 3 of us to serve all the rest of the product. And we embedded we centralized the way that we worked on the data itself, or the way that we developed. We sat as a team with a single roadmap to be able to get a recommendation engine out, to be able to architect how to do this automated ETL. And we architected that like an agile team would, with a backlog, with a sprints every 2 weeks we would commit to, and we would roll out code and we would have version control. But the data that we needed to service and the way that we needed to work directly with the product team that was creating that software. And with 9 different product teams, we needed to embed ourselves in their sprints as well, because we needed to reach out to them in times when we needed to change the way the software behaved for that specific product. So if you think about, in our industry, we had a team that was dedicated towards the sessions product. And there was everything from how you configure sessions, being able to assign rules to those sessions, assigning speakers being able to upload their information. And then you have a data scientist coming in and saying, okay, well, the most valuable data asset we have within sessions is the attendees that are attending that session and how that trickles back to an eventual purchase of a product from visiting that session. So we are going to create this machine learning algorithm that comes up with the top most recommended products based off of the sessions that they go to. But to do that, we need data here, 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 and here, and we need it done in this roadmap so that we can deliver in 12 months. And we would have to set that in their roadmap well in advance, because it would otherwise derail what they were already building. And so that's kind of how we had to split out our data science thinking, is the data science team had to sit together and architect our top prioritized roadmap. We had to go out and embed our day-to-day work function and know exactly how our product was focusing, or what our product was focusing on outside of data science, to help make it a seamless process to continue to release data science initiatives that weren't slowing the rest of the product development lifecycle. Some of the things that we saw, though, or the hurdles that we had to run into with data science, is that without a good roadmap, everything, it was hard to get anything done, because people are so focused on what they're building in terms of a software for customers to be able to configure new things in terms of a SaaS platform. So, their heads down on creating a rules engine to be able to apply attributes. And if you're not thinking about it ahead of time, when you come in saying, okay, we need to develop a recommendation engine and we need 10 story points on this sprint, that was just too much of a task. And so a recommendation engine is not something that just comes up out of the blue. You can actually very well articulate what needs to play into it, and know when to seed in the work that you would need from like a back-end or a front-end developer, and at the right time. And one of the problems that we had is also communicating work that had been done. So if you think of that clustering that we talked about earlier, nobody understands what clustering is. Nobody understands how to break down a segmentation model from a marketing perspective and how they can use that to enhance their lead generation, until you can, as a data scientist, come in and explain what it is, how it's going to benefit them, and how they're going to use it. And
And we did find that communication realm taking a lot more time, and not in a bad way, but that you needed to take time to be able to explain it to the end user and to the rest of the business on how it was going to present value. And it was about as much time. What do I have there? More time? I would say it was about 50-50 in terms of having to present on the results, present on the on what you were going to do, get buy-off on what you're going to do. We would have the company meetings where people would vote on the different initiatives that we had. Here, I'll show an example, where we would go in and say, okay, this is what we're thinking, that an NLP model for customer sentiment. What is the value that that's going to provide to new customers? What about existing customers? And what about our service arm and how that's going to create efficiency? And they would vote on a Fibonacci sequence or close to a Fibonacci sequence on how they would feel that those different elements would impact the business. And based off of that, that's how we would prioritize what we were going to work on next and make sure that things weren't getting derailed in our roadmap deliverables. But this is, it takes quite a communication effort to stand in front of an executive committee that doesn't think in terms of a data science realm and explain the value that you're going to provide to the business and why what you're going to provide is more valuable than something that no one can do today, like being able to schedule a session, right? So you've got that being said by one product line, and then you've got a data science product line coming in and saying, I think we should measure customer sentiment. And being able to weigh between those two takes quite an effort on the data scientists to be able to communicate that. Otherwise, those will be put in the back burner as a nice to have rather than something that can transform your business and the value that you bring to the business. We broke these, I mean, a lot of you guys who've worked in product might know this in terms of agile development, but we had, you know, code reviews of the data science elements that we were releasing. We had deployments, tests, I mean, the whole, everything that you would see in terms of software development, we made sure to replicate on a data science realm so that we could become agile ourselves and deploy agile code regularly that was getting us closer to the long-term goal of what we had scoped in our roadmap. The last thing I'll say, going back to our time, is, has anybody heard of a Mobius strip before? Raise your hands. Okay, so I took topology my senior year in college because there wasn't enough people that signed up and the professor needed an additional, so I got like a C. But the one thing I remember, it's the study of shapes, right? The one thing I remember is a Mobius strip. And a Mobius strip is, so picture like a receipt that you get at the store that's way too long, that you always get, right? And if you connect that in a singular circle, you get a top and a bottom and an inside and an outside to that as you join it, right? But the moment you put a single twist in it and then join it, you want to hold that up?
Oh, sure. I just took the paper and did a twist.
Twist.
Top and bottom are joined
You
different.
break all the properties that you would know about a regular dimensional shape. There is no top to that shape. There is no bottom, and there's no inside or outside, right? And that's when you start to think about time as a dimension, it doesn't really have a direction. And the best that we can do is think of time as multi-directional. And the reason I say this is from a visualization layer, people will want to see it left to right or top to bottom. But if you can actually present them with the ability to see it both top to bottom and side by side at the same time, or actually a spiral, then that's where you're able to realize a lot more intelligence and analytics around time-based decisions. And so, like, let me give an example. So take an event, right? And someone wants to see, okay, an event where 20,000 people show up. They don't grow to be a 20,000 person event overnight. Many of them start out like an event like this, right? And then the next year they might have twice as many, and then the next year twice as many as that. So when it comes to insights, they do want to see, okay, how am I performing today versus this time last year, right? But when it comes to an operational level, they might want to see, how am I doing today versus yesterday? How am I doing today versus a week ago? And it becomes quite a challenge to take a ton of data that has a ton of depth and pivot it on its side to show it a bunch right to left, right? But if you can start to think, okay, I want to see year over year, side by side, but I also want to see a different, I want to maybe see it year over year or day by day or week by week, and let them do more interaction than just one dimensional. That's where you can start to unlock kind of the time component of how people want to see that. And if you start to architect that in your database, we created a table called normalized time links, where we didn't care what the date or time was, but we just wanted to normalize it based off of a center point. So give me an event date, and we'll normalize how many days out this event happened, and how many weeks out, and then how many years out. And then we can actually interjoin that to any timestamp in the system and be able to see anything that we wanted quickly in an ETL-like manner. So yeah, that's all I had today. If you guys want to see more, we do have a podcast. You said you're from Big Squid. I interviewed Killian Dent from Big Squid for that podcast, so it's quite interesting. But I talk about analytics and all things analytics. So thank you. Questions?
So what was the largest data set that you had to work with?
At RainFocus, we weren't over a few billion, but so when we were doing real-time ETL, our goal was under 10 seconds. Every report that needed to be ran needed to run in under 10 seconds. And that was from the time of log on. Having said that, I worked at American Express, and we were in a Hadoop environment, and it was, if you wrote a bad query, you were done for. So, yeah.
Do you have kind of like a hard example of how you were able to communicate some of the importance of the vision that you had with data to the executives when you were at RainFocus? You talked about it's a struggle.
Yeah.
How did you accomplish it? Or were you not successful? I don't know.
No, it was a struggle. I had to learn to be good at presenting, right? And presenting in a simplified manner of let's start with the end in mind. And let's break down how simple this actually is. A lot of people who don't know how to use data, it becomes very overwhelming very quickly and a lot more complex than what it actually is. So as you start to say, okay, we want to start to forecast inventory, for example, well, you can put together a forecast, a prototype of a forecast in a few weeks, and you can think of productionalizing something in a SaaS environment in a couple of months. And that might lose out because someone thinks that's more complex than a 2-year project, but they know all what they're going to get and how long it's going to take and the investment it's going to take. And so what it took for me was kind of shucking off like that chip on your shoulder where you say, data science or data is harder than any other thing, and this is hard, and what we're doing is complex, and really coming to them and saying, this is easy, right? This is the bang for the buck that we're going to get in not a lot of investment in what you're thinking. Let me break it down to the simple steps and the business value that it's going to provide. If I were to give you an exact example, about 2.5 years ago, so when we first started, like a lot of small companies, we bought a BI tool. We wanted our customers to be able to create their own reports and their own visualizations. And we bought a tool called Burst, which is similar to Tableau, similar to like all those Domos and everything. And we white labeled it, made it look like it was coming from our system, and hooked up all the things on the back end so that they could create their reports. And as our product continued to grow exponentially, the amount of effort it was taking for us to be able to continue to configure that thing on the back end was costing us, was eating at our tech debt, and our customers weren't happy. So I had to come to the executive team and say, listen, we need to build our own solution, because what our customers are asking for are simple reports and simple dashboards. And we bought a bazooka of a tool to kill a fly. I think it's going to take us 1 year to build our own drag and drop report builder with simple dashboards and visualizations, and nothing fancy to that. And here's what I need to do, and here's how much it's costing us if we don't do that. So that was kind of an example of what I had to do there.
I was curious, I mean, you explained that each group had a different roadmap, strategy roadmap. Was there a meeting then to kind of integrate the strategy roadmap, and were the data scientists the lead perhaps?
Yeah, so what we did, we had quarterly commits, and we had roadmap prioritization, where we would prioritize all 9 product teams would come and say, okay, this is what we have, our prioritization based off of the scoring that we have. And we would normalize all the scores to prioritize the top priority down to the bottom. And if there was a team that was working on stuff that was really low on the priority list, then they would start to take on different things that were of a higher priority. For us on the data realm, if you imagine, okay, saying you need to work towards like a BI tool and visualizations, and then also saying, okay, we need to do something in the machine learning space as like an MVP. Let's start to prioritize those two, and let's add a stronger priority. That was something that I had to do, and also take a step back and say, okay, we weren't going to do machine learning right up front. We were going to work on a BI tool first because of what we were hearing from the customers and because of the demand that our customers had for that.
But did you, like, your strategy roadmap ever need to, like you're saying, like be the lead, because in order to get to that end in mind, you saw what needed to be built, and so it took different aspects of the other areas.
Yeah, so we, when we decided, okay, we were going to build our own BI tool, we put pause on a team to build a hotel module, so for people to be able to like configure all their hotels. And we pulled 3 developers from that team to help start the data tools team that I talked about earlier on. So yeah, it's quite an interesting battle, if you will, to be able to have those conversations and say, this is what it's going to provide. This is what we're missing out on if we don't have it. And here's, you know, you start to deal with the trade-offs of, okay, if we don't have a hotels team, can we go out and get a third-party integration to buy us some time on that while we work on this, and vice versa. Okay. Question? Yeah.
There's you guys want?
Yeah.
So when you were building machine learning algorithms, do you have a way to interpret your model? I mean, for example, like a way to explain how much each specific feature is contributing to your final prediction, to explain the behavior, why the machine learning model is doing this prediction this way, instead of just viewing machine learning model as a black box.
So I really focused, and do focus on choosing, giving the autonomy to the expert at what they're working at, and saying, okay, our objective, let's say our objective is able to provide better marketing segmentation, right? And putting that in the hands of a data scientist to be able to create that marketing segmentation. I don't care what model they use. All I know is let's get something valuable for marketing segmentation, and let's find a way to measure that value and put some measurement in place so that when we want to enhance our segmentation, we have something to turn back to. And to give you an example, we dealt with adoption a lot, and user adoption in terms of, so we had our engagement score.
And out of the box, the engagement score came pre-configured with points allocated to different, like attending a session, you get 10 points, and registering for a session, you get 5 points. And scanning your badge at a booth, you get 1 point. And looking at that and saying, okay, let's measure how often our recommendation engine is getting configured and how often someone is using or going to a session based off of the, I guess, so the engagement score played into the way the recommendation engine worked. And so we measured how well our engagement score got configured as it compared to people registering for a session and attending a session, and determining whether that was a, whether we were getting the right adoption on our engagement score. Now, in terms of going back and saying, did we choose the right model, and did this, how do we put this in terms of to explain it to a business user? I don't see a lot of value, honestly. So, at least to a non-technical user, explaining a model. Any other questions?
Yeah. So you said when you were, you got really good at presenting when you decided you needed to build your own BI tool. When you were figuring that out, where were you getting the information from? Like, were you just getting it from your own information you were collecting, or how did you start collecting the numbers to start presenting in order to get the buy-in you needed in order to move in the direction you did?
Yeah, so I would say the number one thing, and this would be go to anyone who uses data, is listening to the customer is something that you can quickly get disconnected from, but should really pay attention to, is what are your customers saying? So I had the, we had a customer advisory board, and we did an activity where it was, I had people write on sticky notes, I want to know X so that I can do Y. And we put it up in a grid system of pre-event, during event, post-event, and then sessions, exhibitors, and attendees, because that's how our customers had kind of segmented the way that they work. They had an attendees team, and then they had a sessions team. And so in a room of about 100 people, and it was basically our purchasers, so the executive level and those that are signing out the checks, having them write down what they wanted to do so that they could do what, and pin it up onto a sticky note board was such a powerful thing for me to be able to take back and translate that into a presentation to say, here's where the majority of our customers are struggling and what they want to do, and that's why I think we need to put our time towards it. But I would say that customer feedback arm was one of the most important things for me to realize in terms of how I set a priority on where to go. Yeah.
I'm sorry I came in a little bit late, so you might have covered this, but if you mentioned following like the Agile kind of methodology, like with testing and iterative cycles, and what things in the data science workflow did that really feel good? And were there any pieces of Agile that maybe didn't fit as well? Or like, or was it all just, yeah, this is perfect for us?
So one of the things that was eye-opening to how beneficial it was for me is the value of somebody checking your work, not to discover whether you did a good job or not, but just to put a little bit more responsibility on myself as I was developing, to say this is something that's going to be viewed by someone else that's an expert, has that same skill set as I do. And so for me to come prepared to defend what I had done and walk someone through what I had done in terms of code, that was extremely valuable to our business and helped reduce the number of errors that we were seeing caught by our customers, as someone else could take a second look at, you know, why did you do this? Or what does this mean? I don't understand this. And then the next piece was we had to have like a demo. So you had to be able to demo your work, and that was extremely valuable. Where I'll be honest, the speed at which I develop, it was hard for the daily stand-ups to come in sometimes and say, guess what, guys? I know I said I was gonna like make progress today, but or yesterday, but I completely, that route didn't go, so I'm trying again. You know, like that was that daily stand-up route was a little bit harder. Just to kind of, I found the progress was a little bit slower paced compared to traditional software development. That was a difference for me.
Is that when you're trying to build models then? So to speak? Yeah, because, yeah.
Oh yeah. The other day I was sitting there like time series, dealing with time series data and trying, and then all of a sudden I'm like, you know what? I'm not going to do, it was like an ARIMA model, and I'm like, I'm going to try and work towards a neural network. And that's a completely different like data landscape. And so it was stuff like that where you're just like, okay, then I was in sandbox mode and I'm still no closer. So.
And then the other question I had, did you have like test engineers, QA?
Yeah.
Okay.
Yep. So we had, and so we found, so on our data tools team, we had a traditional QA. And then on the data science team, we started to really we had to write our acceptance criteria in such layman's terms for that QA person to take it on, that we ended up actually shifting our QA to the BI consulting team and having them QA the data science work because they were a little bit more proficient at understanding the work that was being done.
So were they your extra set of eyes and to say, hey, here's what I see, or here's how
they were better. It was more of understanding what our customers were going to use things for, and the BI team was able to kind of say, okay, this isn't going to work for X, Y, and Z customer. The second set of eyes was another developer on the data science team.
Okay, vice QA. Okay.
Can you walk us through that review process? Was that just you put up a code like code on GitHub and they read through it, or did you sit down and walk through that together?
Yes, usually in a code complete kind of environment, it's best to have a dialogue rather than a like, hey, go check out my code and go ahead and approve it. Trust me, I promise, you know. One thing that when we first started, I was the only data scientist, and I couldn't put my own code in code complete and review it. So we had our product owner who was over the data tools team. He was my like, I made him hold me accountable. Like, hey, I know you're not going to understand anything that I tell you, but I just can't approve my own code. Can you please come over?
I need you to be my rubber duck.
What?
I need you to be my rubber duck.
Yeah, exactly.
You just have to sit there and listen.
Just listen to what I'm saying and tell me. Yeah.
So at what speed were you deploying code to production, and do you think your velocity was changed or was improved with
yeah, not only was it improved, but we were able to work on the right things at the right time. So to kind of give you an example, one of the things that we realized as we were building, well, we realized it before we started building our BI tool, that if we were just going to build another tool and then expect people to drag and drop the exact columns that they want and have the right report, we were going to fail once again. If you think you ever go and listen to someone in like 7th, 8th grade that hates math, and they say, well, when am I ever going to use this? And those people become marketers, right? Those people go out into the workforce eventually and they still hate math. And those, like, do you really want to hand over a tool to them that they don't want to deal with and tell them, like, are they really going to get excited to learn how data looks and build their own insights? Because if you start to expect a non-technical user to have that experience, it's going to be a long road for a lot of your customers. So what we decided is, okay, we're going to have out-of-the-box intelligence on top of this BI tool that we're creating. And so when we started that BI tool team, I architected what we call them core reports, core dashboards, and core metrics. And it was somewhere in the range of like 150 to 200 core reports, 35 core metrics, and 50 core dashboards. And it took us about 8 months to build the BI tool, and it took us about 4 weeks to launch the core reports and another 3 weeks to do the metrics and dashboards. And it was because of this fluid pipeline that we had for our development process. Plus, we got the benefit of a single source of truth that people could then copy off of.
So they weren't trying to create something from scratch that they had no idea what it looked like to begin with. So, yeah. Questions? All right, thanks guys.
Thank you very much, Derek. Feel free to hang out and ask Derek some more questions if you want. Otherwise, you're free to go home. I guess you're free to go home when you got here, but thanks for coming, everyone. By the way, there's stickers. Come grab some. Yeah,
My job, yeah. It's 3:50.